ABC is an isosceles triangle. That means this angle and this angle are the same. So in particular, also we know that this side and this side are the same length. Now the diagram is not drawn accurately here. That always tells you don't get your protractor out and start measuring. You've got to use angle facts logic to solve these. We're asked to work out the area of the triangle, and we're asked to give our answer to 3 significant figures. Okay, the first thing is that there's a couple of ways of doing it. To work out the area of a triangle, you have 2 formulas. The first formula you have is that the area is equal to the base multiplied by the perpendicular height divided by 2. So h is the perpendicular height. Okay, that's one formula. The other formula you know is that the area is equal to a half AB sine C, where A and B are 2 lengths and C, capital C, is the angle in between those. So we could do one of 2 things. The first thing we could do is we could try and work out that perpendicular height there, and we could use that. Okay, so let's give that one a go. So let's give method 1 a go. Let's work out that perpendicular height. Well, by that being a perpendicular height, that is surely 90 degrees. Because it's isosceles, this point must be in the middle, so this side must be 6 centimeters. So what have we got here? We've got an angle. Okay, we want to find out the opposite, and we have the adjacent. So we're going to think about using SOHCAHTOA. So we have SO, CA, and TOA. Which of those relationships has an O and an A in it? Well, TOA does. Okay, so what we're going to do is we're going to state what TOA means. TOA means tan of an angle is equal to the opposite divided by the adjacent. So in this case, tan of 54 is going to be the opposite divided by 6, and in particular the opposite then is going to be 6 multiplied by tan 54. Now we don't have to work that out, just keep that as it is at the moment. We're not asked to work out the height, and now we can use this to work out the area of the triangle, because that is the perpendicular height now. So the area must be equal to the base, which is 12 of the whole triangle, multiplied by this height here, which is 6 tan 54. All of that divided by 2. So we can get our calculator out, and we can make sure we go back into normal comp mode. So get the calculator out. And what we're going to do is we're going to type 12 multiplied by 6 tan 54, close that bracket, and divided by 2. And we get the area 49.54, so we get 49.54. We're asked to give it to 3 significant figures. First significant, second significant, third significant, line after it. Because it's a 4, we round off, so the answer is 49.5 centimeters squared. So that was one way of doing it. The other way of doing it is you could have used SOHCAHTOA to work out this length here, if you wanted to. So you could have wanted to work out the hypotenuse there, and you had h, so you could use CA. So you would have said that cos 54 is equal to 6 divided by h. And you could have rearranged that to say h is equal to 6 divided by cos 54. So that was your h. Now you could have used the area is a half AB sine C, where A and B are 2 sides you know. So you know this is 12 and you know this is 6 over cos 54. So the area would have been a half multiplied by 12 multiplied by 6 over cos 54 and multiplied by sine of the angle between them, which is 54. Type that in your calculator, hopefully we'll get the same thing. So we've got a half multiplied by 12 multiplied by 6 over cos 54, and then we're multiplying that by sine 54. This perhaps is more complicated, but hey presto, we get 49.5 as well.